I noticed in the, like a long time ago, when I first started traveling, that I noticed there was a beaver house north of Husky Lake, or northeast, and just out of curiosity, I used to go see it, not knowing much about beavers. But over the time, beavers have really increased.
Technically, it's my hometown, but I moved to New York about 11 years ago now. So, but growing up with Lenny, you know, when we were out hunting, when someone got a beaver that time, it was really a big, you know, everybody heard about it. You know, beavers were really, was really rare that time.
When we first started our work on the highway, it wasn't really an issue, and it was only 5 years ago. But even before I started working, you could notice there was starting to become beavers. A lodge here, a lodge there. It was noticeable then, but now it's really a problem.
Climate change has led to increased temperature and rainfall in the tundra, and this has led to increased shrub growth north of the tree line. This shrub growth, or shrubification, has allowed boreal species such as beavers to move north into the tundra. This, combined with other factors such as decreased trapping, has led to increasing beaver populations in the tundra. Beavers in particular are of concern because they are ecosystem engineers. Their dams create impoundments or ponds that slow the flow of the water down, they raise the water level, and they increase the deposition of fine sediments.
Pans Creek, normally 2 or 3 years ago, we could walk down the middle of the creek with runners on. There was so much beaver dams above it, closer to the big lake, that creek itself was just dried right out.
We went to Water Creek, the creek itself. We followed it from the front to all the way to the back, but that's where our community gets water from. They have a big water reservoir they fill up every year from the creek. And we counted maybe eight beaver lodges in the creek, maybe 10. And when we came back, I started asking questions about what does it do to the water system to have so many beavers.
People noticing it. And I guess it's not only overpopulating, but about our health issues, our waters, our fish, creeks, what they're doing to them.
Healthy streams are essential for healthy fish populations, which in turn support the people who depend on them. To understand how the arrival of beavers, nature's engineering rodents, might influence these tundra stream ecosystems, we look closely at various well-studied indicators of stream health. We focus on things like indicator aquatic insect species, nutrient levels, energy availability, and contaminants to get a clear picture of the effects these dams might have on the watersheds in the Inuvialuit settlement region. To investigate the impact of beavers, we've collected samples from streams with beaver dams over the summers of 2023 and 2024. We gathered samples from several parts of the stream: the water, the sediment, and also aquatic insects.
We do a lot of flying. Last 2 years we flew out with helicopter. It was good to see what else was out there other than the road, and couldn't believe how bad the beaver dams were at some creeks. They were all over. We're doing getting water samples, getting sediment, seeing what was going on out there.
We also recorded measurements of water temperature, acidity, transparency or turbidity, dissolved oxygen, and conductivity, which tell us about the conditions of the water. We also take note of the size and shape of the stream, the plants growing along it and within it, and other features related to the beaver dam. We then collect the same samples and notes from nearby streams without beaver influence. This helps us determine how the beaver dams are changing the stream ecosystem. Once we collected the water samples, we brought them to the lab to analyze the energy and nutrient concentrations. These are important pieces of stream health as they provide a foundation for the aquatic food web. For example, carbon is a key energy source for microbes and plants, which are the beginning of the food chain. By analyzing the water and sediment for carbon levels and structure, we can determine where it's coming from and how easily organisms can break it down. The carbon might come from aquatic plants or plants growing on land. And understanding this helps us learn what's available to the stream's food web.
Changes in water chemistry because of beaver dams can have impacts on biota living in the stream, such as fish and benthic macroinvertebrates. Benthic macroinvertebrates are bugs living on the bottom of the stream, including larval forms of bugs that you may be familiar with, such as crane flies, mayflies, and black flies. These are important because they act as bioindicators for stream health. They give a long-term measurement for the stream, and they're not as mobile as fish, meaning that you can get a good indication of the health of the stream by looking at the benthic macroinvertebrates. And this is because some groups of these benthic invertebrates are more sensitive to disturbance and pollution than others. So if you have sensitive groups, you'd expect that the stream is healthy. Benthic invertebrates are also important to the food web because they reach multiple trophic levels, act as food for fish, and they break down organic material. Streams were grouped by the size of the substrate. We had streams with a rocky bottom and a sandy bottom. Streams were grouped this way because it can have a big impact on the habitat for bugs and fish. We found more taxa that are generally considered tolerant to disturbance and pollution in these slower, deeper stand streams. These include biting and non-biting midges, worms, and clams. Although, what we found was that beaver impoundments have no impact on benthic invertebrate community composition in these sand streams. In these faster-moving gravel substrate streams, we found that the reference sites generally had more sensitive taxa, such as stoneflies, mites, and crane flies. However, the impacted sites with beaver activity were much more variable and had communities more similar to the slower, deeper stand streams.
We also analyzed water and sediment in the lab for mercury. Mercury is a metal that can pose health risks to humans and wildlife. As it moves up the food web, it becomes more concentrated, which is why we're particularly concerned about fish. By comparing the mercury levels in beaver ponds with those of reference streams, we can check whether the availability of mercury in the water and sediment is increasing. While the concentration of mercury in the water itself is low enough to not pose an immediate threat to humans, we're looking to see if there's potential to accumulate in larger fish. If mercury levels do increase to a concerning degree because of beavers, it could be something we need to investigate more in the future as a preventative measure.
Beaver made the water rise in the lake, and off, maybe about 50 yards from the beaver dam, there's permafrost in the bank. And because of the water rising and reaching the permafrost, it melted the permafrost, and it started another creek, not going by the natural creek. The beavers put that one, but it broke the land, broke the permafrost, and completely drained the lake.
I was sort of surprised that not only here, but even in the east and the west of us, our neighbors, Alaskans, they were saying they're having a big problem too with them. You know, they're all over everywhere.
As we continue our research, we'll begin to look for the results from the laboratory analysis for energy, nutrient, and mercury for any patterns. These will help us understand how beaver dams are affecting the health of tundra stream ecosystems and ensure that streams continue to support healthy fish populations for both wildlife and the Inuvialuit in the face of climate change.